Hey, this is Mr. Lowe. Welcome all future mathematicians. Today we're going to continue to talk about reflections, and specifically I want to talk about reflections. Okay, so again, what we're going to do is the same steps of IDing the parent function, writing a table, talking about critical points, and then graphing. And this time we're going to go ahead and talk about domain and range, and also again reflections. So that's going to be the main point to this guy. So this is going to be reflections. There you go. Let's go back to our pencil tool. So let's look at our example here. Again, if we remember from before, we have our two critical point, or our one critical point here, denoted by this positive 2 and this negative 1. Negative 1 tells us that we're going down negative 1, and the positive 2 is going to tell us that we're going to go to the left, the negative direction actually, even though it's a positive 2. We're going to go in the negative direction 2. Okay, so that's going to be our vertex. And also we have something new, this guy right here. This is a negative in front of the absolute, and what does that actually mean, right? So let's kind of take a look at it without the negative, and what should happen, right? We plug in a few points and stuff like that. Oops, it's easy. We plug in a few points, and what should happen is that we start at, if we're ignoring the negative at first, we start back to up. Oops, sorry, back to down 1. We put a vertex right there, and then we'd have a line that goes off kind of in this direction, and then a line that goes off in this direction. But this time it's negative, so we're going to take all of those points, right? And we're going to go ahead and flip it on its negative, right? So we're going to take a negative point. Let's take a nice, I don't know, fuchsia or something like that. So this is that negative, okay? Oops. Control Z. I can't see that because color blindness. Right. So we're going to take this negative point, and it takes all those points and makes a negative. So again, let's make sure we're doing all the things. So our parent function is going to be f of x is equal to x, absolute value of x. Our critical point, so our vertex critical point is going to be at -2, -1, again right there. And then this time we're talking about a reflection, right? So maybe we'll denote that right here. There's a reflection though, so that we know. And then let's do a couple of graphs, and we're also going to talk about domain and range in this video. So I'll go ahead and put that down here, and we'll talk about that in a moment. So yeah, so again we have this point, and again I could check. I'm going to check with this negative now. So if I plug in a -2, that should pop out a -1, and you can double check me, please do. Let's try 0. Plug it in 0. That should be 0. So again, you can check it if you want. That's going to be -0 plus 2 minus 1, and that's going to be equal to negative absolute value of 2 minus 1, which is going to be -3. And you can plug in a few more points, but basically what's going to happen is you're going to take that parent function, right? So the regular v, turn it on its head, and we're going to get a few points here, boop, 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 a few points here. There's that 0, -3. And we're just going to do, oops, I missed it a bit, that's okay. And that's going to be our, so that purple, that's our actual function, right? So we took our parent function, moved it over according to our vertex, and then reflected it. So this blue is the original without this negative, and when you put the negative on there, it'll reflect it down. So okay, let's talk about the let's talk about the domain and range. So the domain is basically how far the graph goes left and right, right? For this particular graph, we're going to say that it goes infinitely, right? So there's a few ways you can denote that. Let's see. Negative infinity, this guy, and x. So domain is in terms of x, so you can denote it this way, or you can denote it, let's put a slash there, this way. Okay, so either way, what that means is that for any x value I put in, I should have a y value someplace, right? So even if I'm talking about, in the millions, if I go far enough in this negative millions, if I go far enough in the negative direction, I should come up with a number. Same thing with positives. I talk about negative millions or negative billions. If I go far enough, I should run into it. Okay. Likewise, with the range, this time range is in terms of y. So range is going to talk about how high up or how low we can go. In this case, range goes from negative infinity. This is y in terms of y. And the highest value that I can have is going to be, highest value I can have is going to be at that vertex, right? So the highest point is -1. Okay? And again, I could write it like this. Negative infinity, comma, -1. And what we should notice here in both of these cases, let me pick a different color. In both of these cases, or in this case, we have a slightly different symbol right here, right? So this guy's going to be an inequality, right? Or not an inequality, but it is an inequality, but we have an equal symbol there. So it includes that -1. In this case, I have a square bracket. So that includes that -1. Okay, so that'll conclude it, and we'll go ahead and get to work on our classwork and practice this a little bit more, and we'll get ready for our next video.